What's up? What's up? What's up? It's your boy, the network. And today's topic is subsection 3.1c, DHCP relay and servers. My favorite topic. This is a subsection of section 3.1, identify, configure, and verify IPv4 addressing and subnetting. This is for the CCNP route exam 300-101 version 2.0. Let's look at the exam blueprint, see where we came from and where we are headed. This is implementing Cisco IP routing version 300-101. As you can see, make sure you're signed up for the correct exam, the correct version. Moving on, we just wrapped up ARP 3.1b. ARP. Where my dog's at? We are now at section 3.1c Charlie, DHCP relay and server. We're going to talk about servers first, and then we're going to talk about relay. I didn't like the way they put it in the exam blueprint here. After that, we're just gonna do a basic, we're gonna do a basic configuration of both. And then we're gonna go a little bit more in depth in the next section, 3.1d, DHCP protocol operations. For now, we're doing DHCP relay and server. So simply put, DHCP relay and server. A server, DHCP server, is basically a service that could be on an actual physical server or VM server that hands out IP addresses to hosts on your network. It could be a computer, it could be a tablet, whatever that needs, because hosts need IP addresses to communicate. Well, how do they obtain an IP address if one hasn't been statically entered into it? If it has to dynamically obtain one, you would need a DHCP service enabled somewhere on your network. Since this is discussing Cisco iOS and Cisco products, we're going to be configuring their services on a router. And that's what a DHCP service does. A DHCP relay, let's talk about that as well. Basically, if you don't have a DHCP server on your network, you got to reach out to a relay agent, DHCP relay. He reaches out to the server and gives you the information you need, such as the IP address, subnet, etc. Let's head over and look at the official definition. As you can see right here, DHCP server. DHCP stands for Dynamic Host Control Protocol. It provides a framework for passing configuration information dynamically to hosts on a TCP/IP network. A DHCP client is a host that uses DHCP to obtain configuration parameters such as an IP address and default gateway from a DHCP server. So as you can see in this picture right here, the infrastructure for a DHCP framework is a host client network and infrastructure. So you have a client that's obtaining DHCP information from a DHCP server. It needs the IP address, as you can see at the bottom. IP address, subnet mask, default gateway, DNS server, lease time. There's other options as well, but those are the basics that it needs to obtain. There's 4 steps to obtaining that IP address. There's the easiest way to remember it is Dora. You remember Dora the Explorer, the cartoon? If you don't, I'll show y'all in another video. I'll show y'all in the next video because I'm going to go more in depth into what DHCP is. Step 1, discover. He sends a broadcast to the server. He discovers the message or discovers looking for that information. And step 2, the server sends them an offer with that information. It's kind of like a contract or some sort of lease. It's like, hey, here you go. Here goes some information. Here go IP address, default gateway, etc. The client looks it over and he says, okay, I like this information. So he sends them a request. And then the server receives it and he says, okay, I got it. He signs it off and he basically sends them an acknowledgement. Here we are. You good to go. Here's your configuration. So 4 steps. D-O-R-A. Dora. That's the best way to remember the steps for DHCP server. We're going to go more, like I said, we're going to go more in depth in the next video, such as options, the port numbers they communicate on, etc. Okay, so DHCP, as I mentioned before, it's a service, right? It's a service that could be, as you can see on the left-hand side, on a server. You could have Microsoft Windows Server 2012 or 2016, and it uses those services to hand out IP addresses. You just enter that information on your server and tell them what information to hand out to your clients. Since this is discussing Cisco iOS and Cisco the products, we're going to be covering those services on either a Cisco router or layer 3 switch. And those products can hand out IP addresses. You just got to enable the service on your router or switch and configure the information on the router or switch, and it hands out those information to its clients. By default, it's already enabled on Cisco iOS, but I'm going to show y'all an example of what it is when it's off. So let's go ahead and move on to Packet Tracer real quick. Yes, Packet Tracer, because it's easier to kind of explain to y'all. I'm going to get more in depth with DNS3. Trust me, we're going to get more into that once we get into, routing with OSPF and all that other stuff. All right, so take a look at this topology here. We've got about 8 PCs here, 9 PCs right here, right? Plus a laptop right there. Kind of odd. And then we got our layer 3 switch right here, and we got our router right here. We're gonna enable those services. We're gonna have this router right here. We're gonna make him hand out IP addresses to these guys right here. Let's take a look at these guys. Let's look at PC6 right here. Right now, as you can see, he got no IP address. He got no subnet mask, no default gateway, none of that information, right? What happens if he tries to ping one of these other guys? Let's say if he tries to ping PC1. How's he gonna do it? PC1 ain't got no IP address either. So this is what we're going to do. We're going to configure those services on the router to hand out IP addresses. Then from that point on, they're going to be able to communicate. It said it was blank. What happens if you put 0.0.0, right? It's blank, right? You won't be able to. Let's do it anyway. Matter of fact, let's do IP config 0.0.0. That's his information, right? So what's his information? PC1 IP config. He's 0.0 also. Let's see if we can ping 0.0. What happens? Ping 0.0.0.0. It ain't gonna work. So you need an IP address to communicate, basically. You see, it's timing out. I ain't gonna show y'all the rest of the pings. All right, first thing we're gonna do is enable DHCP services on this router. First, let me fix the fonts, right? So we're gonna enable, configure terminal, and let me show y'all something real quick. Do show run. Right now, it's off, but normally on Cisco iOS, those services by default are enabled, right? So we got to enable it first. Service DHCP. So now it's on, but now that it's on, if you do a show run again, it's not there. So either way, when it's on, it's just not showing up on your running configuration or starter configuration, right? So next thing we're gonna do is stop the IP address range 10.111 to 10.11100 from being handed out. Why would we want to do that? Let's say we got some IP addresses that we don't want handed out, such as we might have some IP addresses that we want reserved for specific purposes. We could use them for testing purposes. We could use them for static IP addresses if we want. Like say if we want for printer to never change its IP address, we're going to give him a static IP address. But if it's being handed out, you might have a conflict somewhere, a duplicate IP address. So this is one way to resolve that problem, is by having excluded addresses from being handed out. Let's take a look at that IP address range before we do that, though. We got the 10.1.1.0 network, right? That's the network address. I don't remember if you want that address to be used or not. There's a command to actually use it. If I beat y'all to it, I'm gonna put it in the description below. If I don't put it in yet, I'm gonna put a giveaway for anybody that's watching, and give y'all something, whatever it is. I don't know. I'll figure it out. But put a link in the description below and let me know what the command is to actually, that's our pop quiz for today. What's the command to actually be able to use a 0 IP address, an address that ends in 0 like that? It's a network address. 1 through 100, we're going to exclude these addresses, right? So these are addresses that we don't want handed out. Like I said, they could be for testing purposes. We can use them for static IP addresses, whatever the case may be. 111 through 254. Those are going to be our host addresses. That's the addresses we're going to hand out to our hosts, right? And then the 2.255 address, that's our broadcast address. So anybody in that network, if you want to broadcast something, you can send it to that IP address. Remember the other address, if you look in the last video, I believe it's the last video, 255.255.255.255. That's a broadcast address as well, right? That's for anybody in any network. But for this network, that's the broadcast address for that network. the 10.1.1.0 network. So that's for that range. All right, back to the activity. Next thing we're going to do here is, I believe, name our pool. Actually, we got to stop the IP address from being handed out. So you do IP DHCP excluded addresses. That's the command for that. And the address we're going to exclude, address range, you could do one IP address from being handed out, one at a time, or you could do a range. In this case, we're going to do a range, 10.1.1.1 network, and you put the high IP address, which is 10.1.1.100. Those addresses are not going to be handed out now. Next thing we got to do is name the pool. So name actually is DHCP. Actually is IP DHCP pool, and then we're gonna put the name here, right? So we're gonna name it PC, right? And then we're gonna define the network address. So you just put network and then the network address 10.1.1.0 network, then the subnet mask of it 255.255.0. And then next thing we're going to do is put the default gateway. Our default gateway is going to be us. That's going to be their default gateway, me. I was going to put the gigabit 000 interface as the default gateway. We're going to put his loopback, I believe. Let's do show IP interface brief. So the gigabit 000 is 10.1.1.254, but we're going to make loopback address as the default gateway. So it's always going to be up. Remember, loopbacks, they're always on. Their reliability is always usually up. So that's why it's good to make that the gateway. So default gateway is actually, the command for that is default router 1.1.1. That's the default gateway now. We're going to do a DNS server as well. DNS server is also me. Now remember what DNS is, right? That's domain name services. That's a service or a server that translates URLs or website names to IP addresses. So for example, if you wanted to go to rugdoctor.com, you would put in your DNS server, rugdoctor.com is the same thing as 128. or 129.144. whatever IP address. We as humans remember the website names, but the computers remember IP addresses. That's why they invented DNS, so that way it's easier for us to type in a web browser. And that's what DNS server does. I don't remember if the exam blueprint covers it or not. But anyways, so that's the DNS server. That's us. So now that we've configured everything, let's do a show run so we can see. Do show run. And there's the information that we just entered. It's in our running configuration. The excluded address range, the pool name, the network address, the default router, which is us, or default gateway, their default gateway, and then the DNS server. We're not going to really test DNS. This is mostly for this video is for DHCP, so we're not going to test any of that. So anyways, let's test one of these guys. Let's go back to PC6 and see if he getting the IP address now. Notice that these guys had timed out, right? Let's see if he can get one now. IP config/renew. We're being fancy. And we got an IP address now. See, 10.1.1.102. Let's see if one of these other guys can get one. Let's go to PC1. I believe he didn't get one last time, right? IP config. Let's double check. He ain't got one, right? He's still the 000. So let's give him an IP address. IP config/renew. Helps if I could type. And he's 10.1.1.103. Let's see if he can ping 10.1.1.103 now. Ping 10.1.1.03. And we got a reply. See? Simple configuration for DHCP services. Let's move on to DHCP relay. So a DHCP relay, as you could guess, is like an intermediary that takes requests from a DHCP client to a DHCP server. In case The reason why you want to do that is because in case the client is not in the same network as the server. So the relay agent in the middle is going to be taking those messages and handing them off to the server. He just kind of act like a middleman. That's all he is. This is kind of like a proxy, really. So I don't know why they didn't call it DHCP proxy. Maybe because proxy is used all over the place in the IT field. But in this case, it's called a DHCP relay agent. Official definition: a DHCP relay agent is any host that forwards a DHCP packets between clients and servers. Relay agents are used to forward requests and replies between clients and servers when they are not in the same physical subnet. So the relay agent has an interface in the same subnet as the client and an interface in the same subnet as the server. And he just, like I said, he just acts like a middleman. He takes those DORA messages, the D, discover, O, offer, R, request, and A, acknowledge, and he just kind of goes back and forth with them until they done communicating. Let's head over to Packet Tracer, and I'll show you a simple, real simple example of DHCP relay. Okay, as you can see right here, we got, take a look at this topology here. We got the blue network, which is the 2.0 network, and then we got these 3 clients on that network, right? We also got the green network, which consists of a PC, the DHCP server, and his their local area network switch. And then in the middle, now again, they are on 2 different networks, right? We got these clients right here that need an IP address. PC6. Let's take a look at him. IP config. He has a 169.254.181 address. Isn't that IP address you could use, right? No. That's what's called an APIPA address. If you don't know what that is, I'll put a link in the description below. Basically, it just allows you to communicate locally on your network. You can't go on the internet with that IP address. Let's take a look at PC7. He got that IP address. He's also got a 169 address. Can they communicate? Let's see. Ping this guy. They can communicate. They can communicate locally. Can he ping PC4 though? What's PC4's IP address? 192.168.1.0. Can PC6 ping PC4? As you can guess it, probably not. But let's do it anyway, just for the sake of demonstration. I'm telling y'all right now, it's not going to work. He can't ping it because he's in a different network. Plus, the 169 address, you can't use that on the internet. So we need him to obtain a real IP address from the DHCP server. How are we going to do that? That's where this guy right here comes in. He's going to act as the DHCP relay agent. He's going to relay the DORA messages between the server and the clients. None of these guys, all these guys have 169 IP addresses. Let's go ahead and do that. Enable, configure terminal, and then the command for that is IP helper address, and then the address of the DHCP server. But where do you know to where to put that command? You put that command on where you're going to receive the discover messages from. So if you look at this guy right here, let's do a show IP interface brief. The IP address is, this is what we're going to be receiving them from, the FA01 address. That address is the 2.0 network. So that's the IP address, 2.1. So that's where you want to put that command. In this case, interface FA01 IP helper address, and then the address of the IPs of the DHCP server. It could be a server, an actual server. It could be a router. Whoever you're receiving those services and has those IP pools, those DHCP pools, that's the address you want to put. So in this case, it's 192, right? This guy right here, right? 192.168.1.254. So 1.168.1.254. Boom, right? That's the address. So now let's see if PC6 can obtain an IP address now. Well, he has an IP address, but he has a 169 address. That's an address you can only use on a local area network. You can't use it on the internet or on a remote or to a remote network. So in this case, so notice he was able to ping one of the I believe it was PC7 because they are in the same network, the 169 address. But like I said, this is an APIPA address. You can't use that on the internet. So in this case, let's go ahead and renew his address. ipconfig/renew. And now he's obtained that IP address and the subnet mask, default gateway, etc. from the DHCP he received it from the agent, but that information came from the server. Let's see if we can ping PC4 now. Remember what PC4 was? He's in the 1.0 network, so it was this guy. Copy. Actually, we ain't even got to do that. Ping 1.1.0, 1.10. Pinging. Pinging. Timed out. And I would reply. Good to go. So, like I said, simple configuration of DHCP relay. Let's talk about the benefits of using DHCP. First of all, it reduces your internet access costs. If you use an automatic IP address as an address for every remote site, it reduces your cost, because if you gotta buy you actually gotta buy IP addresses for public IP addresses from your ISP, and that can be costly if you got so many remote sites. So if you got DHCP services, it kind of reduces your costs because you kind of using your private IP addresses and handing them out IP address. So like I said, it reduces your cost. ISP is a cutthroat business, boy, because they be selling them IP addresses, and we basically kind of ran out of them. So, but anyways, reduce client configuration tasks and costs. The labor it takes to put IP addresses statically on every, let's say you got 500 clients on your network. If you got to put an IP address for every one of them clients, it's a lot of manual labor. I actually worked for the local government. I'm not going to say which one it was, but they didn't have DHCP services. And we had the technicians call us in, and we used to use this thing called, it was from SolarWinds. I can't remember what it is, but we had to manually give them an IP address to put on the host. It was a lot of labor. So DHCP services really reduce your costs. Centralized management, it helps with that because the administrator only needs to update just a single server when the parameters change. So if you got a new DNS server, or if you change your IP addressing scheme somehow, then you ain't got to change the IP address for every one of those computers. You just change that information on your server, and then he gonna hand those out to the host. That makes it a lot easier if you got DHCP services. And that's pretty much it. Like I said, we just going over the basics of DHCP relay and server. In the next video, we're gonna go a little bit more in depth, such as the options and port numbers, etc. For now, if you like this video, comment, like, subscribe. Again, if you beat me to it as far as what the network address, the command to be able to use a 0 network address, I'm gonna put it in the description below. If you beat me to it, you get a giveaway if anybody's watching. For now, comment, like, subscribe to the network.